Hello, my name is Greg Smith. I'm a hydrologist with the Colorado Basin River Forecast Center, and this is the March 5th water supply briefing for the eastern Great Basin and upper Colorado River Basin and lower Colorado River Basin. Today, we will do a review of the weather in February, look at the current conditions driving the forecasts, look at the March 1st water supply forecasts, the future weather, and as part of a kind of educational series on how we do things here at the CBRC, we'll talk a little bit about the area extent of snow cover and how that impacts the forecasts and what we're trying to do to get a better handle on that. Starting with the February weather, the weather was really dominated by a strong ridge of high pressure, and that shows up on the left-hand side of this slide. You can see a strong ridge of high pressure over the western U.S., parked along the west coast. Most of the storms that affected our area were affected just an isolated part of our area, the upper Colorado River Basin, as these storms dropped down the east side of the ridge. But for most of the month, it was very dry and very warm. By the last week of the month, we finally saw a pattern change, and that's shown on the right-hand side. February 23rd image, where a low-pressure system is shown developing along the California coast and dropping southward along that coast. Eventually it moved inland through Arizona, New Mexico, and Colorado. Brought pretty good precipitation over the southern third of the forecast area, especially from the Virgin River Basin into the Verde River Basin of Arizona and up through southwest Colorado. The precipitation for the month and the season are shown in this graphic here. As you can see, the result of the high pressure ridge with very dry conditions over a vast majority of the area, much below average precipitation, especially in the Great Basin. However, you can also see the impacts of those storms sliding down the east side of the ridge of high pressure, near or above average precipitation in the Colorado River headwaters, also some near and above average precipitation throughout northern Arizona and into southwest Colorado. That was really due to the storm at the end of the month. That storm actually spanned both February and March, so both February and March precipitation graphics might not really show the full extent of that storm system, since it kind of spanned over both the months there. The seasonal precipitation, October through February, shows very dry conditions over the Great Basin, near average precipitation in the upper Green and also the Colorado River main stem headwaters, and this is where the snow conditions are the best in our area right now. Also shows some precipitation near or above average throughout the Little Colorado River drainage, and also precipitation in southern Arizona that was slightly below average, and part of that's due to a good storm system that came through in January. For the first 4 days of March, we actually had significant precipitation over our area as that low pressure system moved through. Anywhere from 2 to 4 inches in parts of Arizona, extending into southern Utah and also into southwest Colorado. Additionally, there was precipitation that really occurred area-wide, but the heaviest precipitation was to the south and at the higher elevations, so this was a benefit. A question might be asked as to whether this actually impacted the forecast. Were we able to take this into consideration when we made the forecast? And the answer would be yes. We had a forecast precipitation available to us. It's always best to have everything already fallen when you make a forecast update, but we did have precipitation forecast available and tried our best to take this into consideration with the water supply forecast update. February was very warm and very dry, and the temperatures reflected it. This here shows an image of the deviation from normal for the monthly maximum temperature on the left and the minimum temperature on the right. You can see that there's just a really significant departure from normal regarding the temperatures, both for the highs and the lows. Monthly temperatures were anywhere from 7 to 10 degrees above average in many areas, and for several areas this was the warmest February on record. We also observed some snowmelt in places, especially in the southern basins and at elevations up to about 9,000 feet. And then streamflow in February, which usually we don't really talk about because everything's frozen, actually increased in some areas as well. Across northern Utah, in the Weber, Provo, and Bear River basins, we saw some February streamflow near or above average. Fontenelle inflow in Wyoming had a record for February. And there was also some increase noted in the San Juan River Basin. Part of that probably due to rainfall, but definitely some due to snow melt. Snow conditions are displayed on this graphic. These are the snow-tail sites, and a couple areas that are circled include southwest Utah and southwest Colorado, where there actually was some improvement in the snow conditions between early February and early March. But once again, these areas are still quite a bit below average or below median for this time of year. Elsewhere, the snowpack remains near or above median in the upper Colorado River headwaters and also in the upper Green River above Fontenelle. Many other areas, though, are near average or below or much below average. Once you get into the Great Basin and Duchesne River Basin of Utah, conditions are quite a bit worse, and conditions didn't really improve at all. They kind of flatlined through February, so if anything, most areas fell a bit further behind. Snow conditions are also shown here as a ranking. Basically, most of these areas are, these areas in the red are actually the lowest on record for this time of year in early March. And those areas with orange, most of those are falling in between the second and fifth lowest on record. So you can see there's quite a few of those showing up in the Duchesne River Basin and also the Great Basin, and at some of the lower elevation sites in Colorado. The period of record for most of these snow-tail sites, it varies, but most of them are around 30, 36 years. So that's, when you're talking second or third lowest, that's quite dry conditions for early March. A sample of the snow-tail sites is shown in this slide, and the green line is this year. So you can see in the San Juan River above Navajo where things really haven't been looking good all season, and the improvement at the end of the month. But the improvement's only it's kind of relative. You look, we only got up to where we were at this time last year, which is in the red. So conditions are still quite dry, even though that storm system did help. If anything, it really stopped a free fall in the guidance. If we wouldn't have seen that storm system come in at the end of the month, I think things would have been fairly grim. The Virgin River Basin, many sites had actually melted out, and you can see that in this slide for Harris Flat on the upper right. Shows where the snow-tail kind of dropped all the way out, and then we had a nice little rebound here due to that storm system. But we're still below average, and we're actually also running out of time. Looking at the average accumulation, we really don't see many more weeks where we actually accumulate snow in that basin. The Dolores River Basin, again, running quite low, a nice little increase as well due to the end of the month storm. In the north, things weren't so dramatic as far as seeing much in the way of snow. The upper Colorado Main and the Green River above Fontenelle are the two areas with the best snowpack in the basin. The upper Colorado did see some storminess. The green line is right underneath the average, so it's just kind of tracking right along that. So there was some accumulation there, just enough to keep it at average. Above Fontenelle, things kind of flatlined a little bit, but there was we were above average anyway, so that area still remains above average. And as you move into the Great Basin and into northern Utah, northeast Utah, flatlined a lot during the month of February, and actually probably dropped a little in the Duchesne before seeing a rebound here in early March. The model snow, this is out of the hydrologic model that drives the forecast, is shown here. Really kind of shows the same thing. There's the early February model snow on the left and the early March model snow on the right. The San Juan River Basin, you can see where there was some improvement, but again, it's still below average. And you can see where in the upper Colorado River main stem, maybe a little bit of improvement, but things overall really unchanged. A little bit of a decrease in the Green River headwaters up in Wyoming. Those areas, again, still remain near or above average, but conditions did drop off there due to dry conditions. And then the Great Basin and the Duchesne River Basin, no improvement. If anything, things worsened a little bit in that area. This is a comparison. I've been showing this graphic. I just kind of got rid of some lines on it for this month. This is showing the model soil moisture coming into the winter season. We don't assume that it makes a lot of change throughout the winter season because of the snowpack sitting on top of it, but it will affect the efficiency of the runoff. And that's on the left-hand side. So the greens and the blues are those areas that are near or above average, and the red are areas below average. On the right-hand side, you can see the model snow. that I just showed you in the previous image. And we're looking for areas where these kind of like match up. So the very northernmost circle here in the upper green, both good soil moisture going in and the snowpack near above average. And the upper Colorado River headwaters, kind of the same thing. Really good soil moisture and a decent snowpack. So these areas are kind of going to benefit one another. Both of these have teamed up with positive in the soil moisture and the snow category. So that's where the best forecasts are, you would expect. The San Juan River Basin, although the snow has improved, had below average soil moisture coming in, and the snow still is below average. And much of the Great Basin, we actually have that situation as well, with below average snow and below average soil. Along the Duchesne River Basin and the Uinta Mountains, good soil moisture but poor snow. So those are kind of countering each other. This is a summary of the March 1st water supply forecasts. As you can see, this map hasn't changed a lot if you've been following along since the one issued in February. Kind of the same areas are doing the same things. There was pretty much most areas are below average, and if you get into the Great Basin and southwest Utah, significantly below average. So no real improvement there. When you look at the upper Green River Basin, Fontenelle, upper Green's kind of doing the best, along with the Colorado River headwaters. We're in that 90 to 100% category there. But again, you know, things are kind of a mix. Lake Powell's at 5.1 million acre feet as of March 1st for the forecast, which is 71% of average. There's been some improvement in McPhee Reservoir in Navajo and southwest Colorado, but these are still below average, and Navajo is significantly below average. So it's kind of a snapshot of the forecast issued on March 1st. This shows the trend and the change in the volumes forecast between February 1st and March 1st. And some are minimal. In Fontenelle, just a small change, but we can actually see in the southwest part of Colorado there was actually a little bit of an increase. Not really super significant, but it was an increase over what was issued on February 1st. That's something we really haven't seen for a little while. We also had but a decrease kind of in the Gunnison and in much of the Colorado forecast, and then a decrease overall in the Great Basin. Some of those dropped as much as about 15% of average between February 1st and March 1st. March 1st water supply forecasts. This is for the March through May period in the lower Colorado River Basin. The Verde River Horseshoe now jumps up above median due to recent rainfall. The area is very saturated, so anything else is probably going to run off pretty quick. And then things kind of taper off as you go east of there into the Salt and the Gila River Basin. A couple of evolution plots I wanted to throw up here real quick. This shows the Lake Powell forecast evolution plot. So just a reminder, that dark blue line in the middle is the raw model guidance, 50% exceedance volume as we move through the season for the April-July period, and the red lines are the actual official forecasts for the first of the month. And you can see how in February there was really a free fall going, and this was happening over a lot of areas due to the warm, dry conditions. And then we rebounded here towards the end of the month as storminess and increased precipitation was observed in the area. So that was one positive. There is a mid-month update that goes out for some of the major reservoirs. So for Lake Powell, it was 4.9 million acre feet. So there wasn't actually an increase since mid-February of a couple 100,000 acre feet for Lake Powell. And we can see kind of how even after the forecast, as unsettled weather continued to occur, the model did jump up a little bit above what was currently issued on March 1st. A couple more plots here, just highlighting what's kind of been going on in some of the other basins. Dolores, McPhee were kind of used to represent the southern basins. Again, really in a free fall after the February 1st forecast. The model guidance dropping things way down, and then that free fall was kind of stopped and actually reversed a little bit as precipitation was observed in the area, and we actually saw some snow in that area. Not so much of a change in the blue, because we were getting some, this is in the Dillon Reservoir, so this is in the upper Colorado headwaters. Not a big change here, because we were seeing precipitation occur at times through the month as those storms drop down the east side of the ridge. Looking at the future weather coming up, we can see on here over the west coast a ridge of high pressure building. There's a weak low down along off the coast there along the southern areas, but that's probably not going to do much. This ridge is going to become the dominant feature for the next week as it moves in and builds over the west. So we'll see temperatures again rise to above average conditions and things dry out. The model guidance from the meteorological models, they're somewhat consistent in building this ridge for the next 5 to 7 days. This would be valid as of Saturday. This cursor I have is kind of circling around the center of the ridge. Low pressure down to the south, but it's fairly weak and it's fairly dry, isolated showers at best. A week from now, or a week later, looking at Saturday, this is what one of the models suggests, is that we will get back into a bit of an active pattern, at least for that time. Again, this one develops a low pressure system that kind of develops over the southwest again. Another model brings in precipitation, but it doesn't quite develop the low in this area. But I guess the big message would be that it does show a more active pattern again next weekend, but it's really hard to, there's a little bit of inconsistency and it is a lower confidence forecast period. So the details we don't really know yet on where the heaviest precipitation will be, but it is something that hopefully we'll see develop. However, in the short term, the confidence is pretty high, and you can see the precipitation forecast for the 7-day period between now and the 12th, not showing much of anything over our area. As far as the longer range outlook, this is the Climate Prediction Center 90-day outlooks issued here towards the latter part of February. It does show increased chances for above average precipitation over most of the CBRC forecast area, especially over Colorado, over the Rockies, and over western Colorado, and extending maybe into a little bit of the Green River Basin. And temperature-wise, again, sticking with increased chances for above-average temperatures over much of the area, from the Upper Green River over the Great Basin, Duchesne, and down into Arizona, with much of Colorado kind of left in the equal chances category. There was an announcement that came out this morning regarding El Nino. We've been talking about this throughout the year, that there was a 50 to 60% chance of a weak El Nino developing. They've actually gone ahead and declared that we are in a weak El Nino situation. El Nino is basically warmer than average sea surface temperatures in this area, where it says warmer than normal in the equatorial Pacific. That has been persistent throughout most of the winter, so that really has already been there. What was lacking was kind of a coupling to the atmosphere. Usually the atmospheric winds are affected by these temperatures, and they're actually starting to see some of that occur now. They're seeing convection in areas that they've kind of been expecting it, but it hasn't been occurring. So enough has occurred now for them to indicate that there is a weak El Nino. What does that mean for us? Well, El Nino itself doesn't really correlate all that much with runoff in much of the basin. It's really focused on the lower Colorado River Basin, so that would be Arizona. But we're also getting into a period of time climatologically where it's much drier in Arizona. So the impacts at this time of year, we're not expecting them to be really all that significant in our area. However, if an El Nino is still going on as we enter the winter season, then that's a different story. That may be something to a little more hang your hat on. And that is possible. This is the latest raw model guidance showing the likelihood of an El Nino into the future. This has kind of changed a little from what was out there just even 2 or 3 weeks ago. So currently we're in weak El Nino conditions. There's still a expectation that we'll probably drop back into neutral conditions later this spring. But then beyond that, it gets a little bit muddy. The raw model guidance kind of shows that there's a tendency back towards El Nino for the remainder of 2015. So that's something we'll have to watch, and that maybe will be a positive sign for our southern basins if that does develop as we enter next winter. So I'm going to switch gears here for a moment and just talk a little bit about area extent of snow. This whole idea of throwing a few slides in here about our methods and process is to really give our users, our customers, a little bit of insight into how we do things here. And also what we're looking at and how we're trying to improve the forecast. So we thought we'd take the opportunity each month with these water supply briefings to throw 4 or 5 slides in. They're really simple. I know they just touch the surface, but just to give you an idea of what we're trying to do and how our model works and how we're trying to improve what we do. Area extent of snow is one of those states in our model that's really kind of critical. It's really important to how the model times the runoff. It is important to the volume of the runoff, and really it's important to the seasonal recession. When have we reached the peak? When are we going to see the streams turn over and start dropping? So it's has very large impacts to those recession forecasts as well as the late season monthly volume forecasts, and those can be really critical if you're trying to fill a reservoir. So our goal is to be able to fine-tune these model states, and we want to, in these model states, the snow cover is related to the snow amount within the model. This slide here that I'm showing is just a snapshot of on one particular day of how our model sees snowpack, and this is for the Lake Fork near Gateway Basin, which is in the Gunnison River Basin. And basically we have 3 different elevation bands here showing different snow cover percents. A lower elevation band between about 8,000 and 9,000 feet that on this day is saying it's 50% snow cover. This is what the model is saying. Middle area between 9,000 and 11,000 showing just under 100%, and then the upper area saying it's totally snow covered. So it's critical when we get into the season, we start melding. How much snow is in here is related to the snow cover, and that can be off just a little bit and really affect the recession and late season volume. So that's something we really aim to try and improve. So what we're doing, this follows a little bit from the dust on snow conversation that we had in the last webinar. We're using the same type of data. We're getting the same satellite information from the Jet Propulsion Laboratory of observed satellite snow cover data. And so the goal is we're going to grab that information, we're going to process it, put it in the proper format, and then try and develop a relationship between that observed data and what our model says as far as the snow cover goes. There's a lot of considerations we have to do in developing this relationship. A key one is the tree canopy that exists, because tree canopy is going to tell the satellite there's probably less snow cover than there really is. So that's something we need to know. And ideally, we will be able to take this model snow cover, and once we have this relationship between the observed data in a historical sense, we can actually predict what this typical observed extent should be. When we compare this predicted observed with what's actually observed, if we notice big differences, that's going to flag us that we need to jump in and take a more detailed look at this particular parameter, this particular state for whatever river basin this is being flagged for. Basically, it gives us something to look at where we might potentially remove or add snow in the model based on the result. We're in the process of testing this, and then if it looks like it's going to work out well, then we may implement this operationally, hopefully maybe this spring. But it is, again, something that we'll actually use during the melt period. This is just an example of what a grid looks like. Again, this is the Lake Fork Basin. This is the satellite snow cover showing, and on the right here is the percentage of the cover for each of these grid cells. Clouds are always a problem. That's in the gray. If you get into like a month of just total cloudy weather, it's really a struggle to use this data. But on clear days, you can use this, and hopefully it gives you a chance to update or double check your snow cover. So this is something where we're trying to use some of the newer technology and new data out there to do this. And again, it shows the elevation bands, and it shows some areas where you see a lot of these little grid cells saying, the snow cover's not that great, but we actually know that there's a lot of tree cover there, so that's one of those things we have to take into consideration when using this. Just in some simple initial results, we did take a look at this and found in the calibration where there were several years where it was flagged, and it probably would have helped. We had a couple years in 2000, 2004 where it said you don't have enough extent, and we actually did underpredict that year in the calibration, so adding snow would have helped. 2008 was just the opposite. We had too much extent in the model according to this, and we did overpredict it. So that there's a couple years that gave us some confidence that, hey, this may be something we can consider using. There were a couple other years, 2009 and 10, where we also had some issues, but it turns out that it might have been better if we used the dust on snow approach. Used those what we talked about in the last webinar, the last briefing, by modifying temperatures based on it being a dusty year and probably absorbing more solar radiation. So maybe it was a timing issue with the melt. So that's we're learning more as we go through this, and the whole idea is here, I guess, is just to show you kind of some of the things we're looking at to try and improve the forecast process. So that's really all I've got today. If you go to our webpage at www.cbrfc.noaa.gov, you can click on water supply at the top, and you'll get an image like this that shows all of the different water supply forecasts. You click down into these, and it'll bring up the daily evolution plot, so you can track this information daily. There's more here than I could actually go through in a briefing like this. But click around. Please give us a call if there are any questions or concerns, or you would like some help finding certain types of information. We have scheduled a webinar for March 10th at 1 p.m., which is a peak flow webinar. So Paul Miller and probably Ashley Nelson will be involved in that. And then April 7th and May 7th, we're back to a morning presentation for the water supply webinars, and we'll update you if we decide to add any additional ones between now and then.